Topic 5 talks about linear relationships, and we are going to start with section 5.1, which is what is a proportional relationship. We have 3 different ways to show proportional relationships. The first way is with a table. A table will show a proportional relationship when the x values are all multiplied by the same number to get their corresponding y values. So let's take a look at an example of a table that has a proportional relationship. So we are going to start with our table with x and y in it. And I'm going to fill out some x values and y values, copy those down. So we have the point 12, 4, and then we have 36, 12, and then we have 18, 6, and last we have 30, 10. Now, this is a proportional relationship because every time I divide y by x, I get the same answer. Look here. Every time I divide y by x, I get the same answer. So, let me show you what I'm talking about. If I take this y, 4, and divide it by the x that is paired with it, I get 4 over 12. That equals 1/3 when I simplify it. If I look at the next pair of numbers and I take the y, which is 12, and divide it by the x, which is 36, 12 over 36 is also equivalent to 1/3. The same is true if I do 6 divided by 18. So 6 over 18 also simplifies to 1/3. And lastly, I would take the 10 and divide it by the 30. And if I do 10 over 30, that simplifies to 1/3. So that means that in that table, we always multiply the x by 1/3 to get the y. So we always it's written right there for you, sorry. We always multiply the x, I'm right here, we always multiply the x by 1/3 to get the y. And since we always multiply by the same number to get the y, then that means it's a proportional relationship. Now let's look at another table that is not proportional. So again, this is a non-example. So take a look there, non-example. This is one that doesn't work. So if I have a table of x's and y's, and I have 2, 4, 3, 8, 4, 16, and 5, 32. There is most definitely a pattern, but in order for this to be a proportional relationship, the y value divided by the x value has to equal the same thing every time. So this one is not a proportional relationship because y divided by x does not result in the same answer. Let's take a look the different pairs. So if we take 4 divided by 2, I get 2. Then if I take 8 divided by 3, that means I should get a 2 if it's proportional. But when I do 8 divided by 3, I get 2 2/3. So right there I can stop and say this is not a proportional relationship. So we don't always multiply the x by the same number to get y. If y divided by x does not equal the same thing all the way down the table, then that means it is not a proportional relationship. All right, let's take a look at the next part, and that is looking at a graph. So we could also look at a graph to determine if we have a proportional relationship or not. With a graph, it must be a straight line that goes through the origin. And you should know what the origin is, but if you don't, this is a reminder. It is the point 0, 0. So let's take a look at some examples here. As long as I have a straight line that goes through the origin, it will be a proportional relationship. So I have my origin, which is right here in the middle, and then we need a line that goes through that center. So as long as your line is straight and it goes through the origin, it's going to be a proportional relationship. Now, it doesn't matter if the line goes down from left to right or up from left to right. Again, the only two rules are that it is a straight line and it goes through the origin. So here's another example down here where the point that is the origin is going to be on the line that I draw. So as long as those two rules are followed, then it is a proportional relationship. Now let's go over to the non-examples. It's possible to go through the origin but not be a straight line. So here's an example where the origin is part of the graph, but it's a curve instead of a straight line. So it does go through the origin, so it meets part of it, but it's not a straight line, so it's not a proportional relationship. Here's an example of one that does not go through the origin, but is a straight line. So we could have something like this. And this is a non-example because remember the two rules are it has to go through the origin and it has to be a straight line. So this is a straight line that doesn't go through the origin, so therefore it is not a proportional relationship. So that was the second way. So again, the first way was to look at a table. The second way is to look at the graphs. And now the third way is to look at the equation. Oh, too far. All right, so we are going down here to these notes. The equation is the third way to see if something is a proportional relationship. Equations must be able to be put into the form y equals mx. We call m the constant of proportionality. That's an important term. Constant of proportionality. That is what the letter M is. This is what we multiply x by to get y. Remember, in our notes about tables, the number that we always multiply x by to get y is constant, and that's why m is called the constant of proportionality. The m is equal to y over x. So if you remember, in our table, we always did y divided by x to see if we got the same answer over and over again. That was finding the m, or constant of proportionality. So an example of an equation that is a proportional relationship would be y equals negative 15x. We always multiply x by negative 15 to get the y. So we would say that the constant of proportionality, which we call m, is negative 15. So this example, y equals negative 15x, is an example of a proportional relationship. A non-example would be y equals negative 15x plus 8. Because we added that 8, that takes it away from being a proportional relationship. So in order for it to be a proportional relationship, you cannot add or subtract anything in the equation. So to summarize, we have 3 ways to determine if a relationship is proportional. The first is a table, the second are graphs, and the third is equations. So make sure you study these notes in order to help you with the homework for section 5.1.